Welcome to our today's class. It is management accounting. We want to continue from where we stopped last time. We were looking at the cost estimation methods. We had looked at the first two, the high-low method, and we had looked at the account analysis method. My name remains to be Wafula Godran. I will be taking you through this management accounting. We will pick from where we left last time. So just to do a recap on the high-low method, we said that high-low method is another method that can be used to predict the future cost of running a program or an activity. So we were looking at the concept and we said that under this method, a statistical data from historical information will be provided by a company, and the work of the accountant is to determine from the data given the highest level of activity and the lowest level of activity together with their corresponding costs. Now, with these two areas or these points established, we are able to determine the equation. We are able to come up with the cost function in the form y is equal to a plus bx. So our last class, we said that once we understand we pick the 2 points, the highest and the lowest with their corresponding level of cost, we are able to come up with the equation, the one we are calling the cost function. We establish the cost function in the name y is equal to a plus b x. And this is what we said as one of the methods of dealing with cost estimation. So this method we are looking at is the high-low method. The high-low method. I'm hoping that you still remember that. So we established the cost function in the form y is equals to a plus bx, where we said that y stands for total cost, the total cost for that period. A is the total fixed cost, cost. Then we said b is a constant, and this constant represents variable cost per unit. Then we have x. Now x is the activity level that we have picked. That is the activity level. That is what we said last time. Now our equation is going to be established in this form, and we need to know how to arrive at each point. So to bring out the concept clearly, we are going to look at an example, and we are choosing one of the past papers question to use as an example. So we are choosing a revision question 2. This is question 2B Roman 1, question 2B Roman 1 of May 2018, CPA section 2. That is a question that appeared in 2018 May management accounting. So the question, as you can read, the question says, let me read for you. So the question is here. Okay, we are told the administrator of Chebatok Hills Hospital would like to establish a cost formula linking the administrative costs involved in admitting patients to the number of patients admitted during the month. I repeat, the administrator of Chebatok Hills Hospital would like to establish cost formula linking the administrative cost involved in admitting patients to the number of patients admitted during the month. The admissions department's cost and the number of patients admitted during the last 8 months for the year 2017 are given below. So the data is given here. We are given the month, then we are given the number of patients admitted, number of patients admitted, and we are given admission cost. We are given the admission cost. So the months are May, June, July, August, September, October, November, and December. The number of patients admitted is given as 1,800 in May, 1,900 in June, 1,700 in July, 1,600 in August, 1,500 in September, 1,300 in October, 1,100 in November, and 1,500 in December. The admission cost is given as 14,700 for May, 15,200 for June, 13,700, then we have 14,300, 14,000, then September has 14,300, October has 13,100, that is October, then November has 12,800, and finally December has 14,600. So that is the cost as given in this question. Required, Roman 1, required, the question states, using the high-low method, estimate the fixed and variable components of admission cost. Using the high-low method, estimate the fixed and variable components of admission cost. So we want to see what happens. Now, when solving this kind of a question, allow me not to erase so that we can use the information as given. So when solving a question like this, the first thing that we've remembered is that our function is y is equal to a plus bx. That is what we first remember. Then, using high-low method, we go and pick the highest and the lowest activity level. If we walk through the activity level, this is where our x is, because that is the number of patients representing the activity level. Then this cost is our y. So we walk through x and pick the highest level of activity. If you can see, the highest level of activity is in June. So June happens to be the highest level of activity. We establish June with its corresponding cost of 15,200. The lowest level of activity is in November. November has the lowest level of activity, which happens to be 1,100 number of patients, and the total cost there is 12,800. So we go and say we are going to establish what B is using the change in Y cost over the change in X, the activity. So we'll say if we want to get B as that variable cost per unit or the constant, first we get the change in Y over change in X, which means change in Y, that is change in cost, will be the highest level of cost minus lowest level of cost divided by change in X will be the highest level of activity minus lowest level of activity. So that will be 15,200 minus 12,800 divided by 1,900 minus 1,100, like that. So that will give us, it will give us, if we take 15,200 minus 12,800, you get 2,400, sorry, divide by 1,900 minus 1,100, you get 800. So 2,400 divided by 800, it will automatically give you 3. So that 3 becomes our constant, and that is the variable cost per unit. So if we wanted to know the variable component of this question, we can say we've already known variable cost per unit is 3 shillings per every patient that is admitted. Now, we don't stop there. We go and get the total variable cost and total fixed cost at whatever given point. So in this question specifically, they were asking for us to break down the fixed component and the variable component. So this is the variable component. That means the change in X will be changing around the 3. Now, let's go to the equation and pick any, we pick one of the points that we have identified. We can either pick the highest or the lowest, and we use the data. So let's say we have picked the highest. Let's say we have picked the highest. So if we picked the highest, if we picked the highest level, we find that at that point, X is 1,900. Y is what? 15,200. We know what B is as 3. And now what we do not know is A. And A is fixed cost, which should be constant. So we come and say, we are going to fix all this data in the equation, in the cost function, and it will help us establish what A is. So that can be fixed like this. We say Y is equals to A plus BX should be the same as Y is 15,200 equals to A, which we don't know, plus B, 3, times X at that point is what? 1,900. So if we make A the subject of the formula, then we automatically find that A will be 15,200 minus, if we multiplied 1,900 times 3, it would give us 5,700. So minus 5,700. Therefore, fixed cost is 9,500. 9,500. That is the fixed cost component. So this is, we've gotten, this is fixed cost component, fixed cost, and this is variable cost per unit. So that's how you answer that question using the high-low method. I'm hoping that that concept is clear now, and you can easily use it to answer other questions. In addition, if they had asked us something extra, maybe they may ask you to establish what? The cost function. They may ask you to establish the cost function. The cost function, we will come and say Y is equal to now 9,500 plus 3x. This becomes the cost function. That is the equation. So we have established the equation. This equation can be used to predict any level of activity. If, for example, they told you what will be the cost of producing 20,000 or maybe 2,000 units, we just come and fix the 2,000 in the equation, and we are able to predict that. Thank you so much for that. We move on to the next method. And the next method is what we are calling the scatter graph method. The scatter graph method. So let's look at the second one. The scatter graph method. So, cost estimation using a scatter graph method. Using scatter graph method. Aha. So now with this method, we draw a scatter diagram on a Cartesian plane, which we establish the y and the x axis on the graph. After we have constructed this graph, we can visually see and observe the items that we are relating, the relationship between x and y on it. By observation and inspection, we are able to identify the relationship between x and y. We can tell whether there is or there is no relationship depending on how the points that we will plot on that graph relate. So it is very easy for us to use the points plotted on that scatter graph to establish the relationship. If we are convinced from our inspection and observation that there is a relationship between x and y, then we are likely to draw a straight line joining any two or more points that happen to have a relationship. Then from that, we are able to establish that line cost function using that line, and we are able to tell how the rest can be predicted. So this is how we draw this line and this graph. We may be given a graph like this. If we plot on this graph, we have y and we have x. Then a scatter graph will look like this. A scatter graph will look like this. You will find that there are items that we are trying to use to show the relationship. Now, when our items on this scatter graph looks like this, we can easily see that it's very difficult for us to deduce the relationship between x and y. We cannot actually conclude by observation that there is any relationship. So in this scenario, if it looks like this, we say there is no relationship. There is no relationship. There is no relationship between x and y. In this manner, there is no relationship because we can't actually tell. We can see all these items grouped together at one point. So we are not sure whether they have been grouped as a result of the relationship between x and y. But there is another one that can be drawn, or you may get another one that looks like this, y and x, so that you are given that the items have been plotted like this. They have been plotted like this. So if you look at this just by observation, you can easily tell that these items we've plotted are moving towards the right on the upward slope. And you find that if we are convinced from our observation that yes, there is a relationship because of how they look like, then we will be required to draw a line, and this line is supposed to join two or more points on this graph. So if we draw a straight line that joins 2 or 3 points that happen to fall in the data that is given, we can easily see that yes, this one, there is a relationship. So this one we say that there is a relationship. There is a relationship. There is a relationship between x and y. There is a relationship between x and y. So this is what we are calling a scatter graph. Now, if you are given a question and you want to use a scatter graph to predict or to estimate cost, what do? From this line, you come and pick any 2 points. You come and pick any 2 points because this one is a linear line. It's a straight line. This is what we call a line of best fit. Line of best fit. So this line, we come and pick 2 points. We can pick this point and name it A, and we pick this other one, we name it B. So with these 2 points, we establish the slope. We establish the slope. Other books call it gradient. We establish the slope. So on this slope, this will be the change in x, and this will be the change in y. So we are going to say the slope or the gradient of that line of best fit is going to be change in y over change in x. So that means we come and pick the value at y here, and there is this value. Let's say this is 20 and this is 10. So that will be 20 minus 10. What about x? X, we come and pick it here like this. And let's say, for example, this is 7 and this is 9. So that will be 9 minus 7. So the gradient can be established from that scatter graph that we initially had. And that will be, this will be 10 divided by what? Divided by 2. And that will be 5. That becomes the gradient, and that gradient is a constant which we are calling in management accounting as what? Variable cost per unit. So you see now, we have been able to establish our B in the equation. Y is equal to A plus BX. We have been able to establish this B, which is the slope, or which is the gradient. So we've been able to establish it using what? A scatter diagram. We have managed to get that as a scatter diagram. Now, once we get B, we are able to pick any point from the points that we have to establish the equation. And that is how this method is used. That is how this method is used. The advantages of this method is that it takes into account all the observation, unlike the high-low method. With the high-low method, we only pick the highest and the lowest point. But here, we have to draw a line that will cut across the lines and give us a balance for all the other points that have been developed. Number 2 is that it is easy to apply. Once you know how to obtain the gradient, then we can easily use it to predict. Like, for example, let's say when x is 9 and y is 20, and we know b is 5. So the equation will be, first of all, we can get the A, and A will be fixed cost. We will say that 20 is equal to A plus 5 times what? 9. So that will be 45. That will be 45. So A is negative what? Negative 25. So we have gotten A, and once we get A, we can now come up with an equation and say y is equals to negative 25 plus 5 what? X plus 5x. That becomes the equation. So it is very easy for us to apply this method. So that is what we are calling the scatter graph. A disadvantage of this method is that it cannot be used for 2 or more independent variables. We should have only one independent variable, and that's when it can be used. Number two, we cannot measure the size of probable error. Actually, we cannot tell, because if somebody picked different points, we can be sure he's going to come up with a different gradient, because the gradient changes. We assume, we find that different points, like if we drew a line that passes into different other points, then the gradient is likely to change. Another one is that it is subjective to some extent. It is subjective to some extent in what you are likely to come up with. So that is how we use a cost. We use a scatter graph to estimate cost. Now there's another method, the last one, which is now more examinable. This one, it rarely misses in the exam. And that's why when we started this topic, I told you we have now entered the exam paper. The topics we are covering from cost estimation, we are actually covering the exam. So let's look at the last method. We are calling it ordinary least squares regression method. Last method is what we are calling the ordinary least squares regression method. Simply put, as simple regression analysis. Simple regression analysis. Simple regression analysis. So this one, it rarely misses in the exam. Make sure that you understand exactly what we are going to do so that you will not have a problem. Now, with this method, it uses a statistical model. And when we talk about statistical model, we are mentioning the statistics, the statistical items, and items like the mean. We are going to encounter somewhere where we will be calculating mean. So it uses that statistical model to measure the amount of change in one variable, which is dependent variable, in relation to the change in another variable. So we will always be presented with the data which is maybe historical, and from this data we will be required to tabulate it so that we can identify, we can come up with the various components that form the equation. The equation that we are going to use here will tell us exactly what we need to come up with from the statistics that from the data that will be provided. So once we identify or we establish that there is a correlation between the items that have been presented in this statistical data, we try to fix our interpretation around the cost function in the form of y is equal to a plus b. So once we establish the relationship exists in this data, we put this relationship in the form of a plus bx, and this is what we have called before a cost function. This is a cost function. So once we have established that, we use the cost function. Now, we use the cost function now to do our forecasting and prediction. So in this question, in this function, we will still remember that y stands for total cost. Total cost. A stands for fixed cost. Fixed cost. B is the variable cost per unit, which is expected to be constant. And X is the activity level. The activity level, which can be in units. We know that. From there, what you need to understand under this method is how to arrive at A and B, because these have been the items that we've been looking for, or the constants we've been looking for in other methods that we have used before. Now, under this least squares regression method, I'm going to give you specific formula that you need to use for you to get B, the value of B. Actually, we are going to change a bit. It will have several components involved, and that's why it is called a statistical model. So we start by getting the first step that we get, step 1, you always get what? You get the value of B. The value of B will be given by n summation of xy minus summation of x summation of y divided by n summation of x squared minus into brackets summation of x close the bracket and square. So we are saying the first step is you get the value of B. B is given by n summation of xy. That's why I told you we will have to tabulate this information. Then summation of xy minus summation of x summation of y over n summation of x squared and summation of x, we square it. So we understand n is the number of items given. Then we understand what x is, we understand what y is. So when we say summation of x, summation of y, we have no problem, you can get that. Then step 2, sorry, after we've gotten what B is, now we go and get what? Get the value of A, which is fixed cost. And this one now will be given by summation of y minus B summation of x divided by n. We will be using summation of y minus B summation of x divided by y. So once we get that, now we will go to step 3. Step 3, which will be now complete the equation. Complete the equation in the form y is equals to a plus bx. Very simple. So the only serious task that you need to understand is the formula and how to get how to tabulate the data as given. So we are going to look at an example, and we look at a past paper question so that we can be very sure that if we get a question that asks us to use the high-low method, we are able to tackle it. The account analysis, we are able to tackle it. And also the regression analysis method, we are able to tackle it. So before we look at the example, I want you to notice this, that there are some characteristics that we've learned from this equation. One, it is objectively determined. Number 2, regression analysis, it makes use of all the data or observation. It also minimizes the sum of the squares of the error. Actually, it reduces the error, and we will see that when we will be looking at an example. So there is an example that I want us to look at. Then we look at a past paper question. After that, the topic will be complete. So let's look at the example. Let's look at the example. So the example here says, the following table shows the number of units of a good produced and the total cost incurred. The table below shows the number of units of a good produced and the total cost incurred. And this is the table. We have the units produced on one side and we have the cost. So we are told when 100 units were produced, 40,000 was incurred, 200 units, 45,000, 300 units, 50,000. 400 units, 65,000. 500 units, 500 units, 70,000, yes, 70,000. Then 600, 70 again. Then 700 units, 80,000. Required. We are asked, determine the variable and fixed cost components. So Roman 1, we determine the variable and fixed cost components. Roman 2, determine the cost function in the form y is equals to a plus bx. So cost function y is equals to a plus bx. In Roman 3, what will be the cost of producing 850 units? Cost of producing 850 units. So that is the example we have. So I think we can look at it and see what we get. So looking at this kind of example, we've been given the units and we've been given the cost on one side, and the questions given here are as we can see. So this is how we are going to solve this question. Solution. In our solution, we have first of all to establish that y is equals to a plus bx. Out of this, we know how to get b as n summation of x, y, minus summation of x, summation of y. That is what we have said before. Divide by n summation of x squared minus into bracket summation of x, like that. So that is what we have to establish. Then we also establish that a will be given by n will be given by y, that is summation of y, minus b summation of x divided by n. So that's what we know as at now. Then we go to the data and tabulate it. So once we have known that, now we come and tabulate what? The data to obtain the items that we can see. So the first item in this table of ours, we are going to tabulate first the x, the y, we have xy, we have x squared, yeah, we have x squared. I think that's all. So on the side of x, we were given 100, 200, 300, 400, 500, 600, 700, like that. Y, we were given 40,000, 45,000, 50,000, 65,000, 70,000, 70 again, and 80,000. That is what we were given. Now, xy, for the purpose of xy, allow me to assume we have our thousands up here, so that the data that is appearing here let it be a data that is made of less zeros. So that will be like that. Then on this other side of x, let's also assume we have 2 zeros up here to reduce the number of zeros. So let's assume we have 2 zeros up there. Like that. At least it will be now okay. So if we are getting xy, this will be 40. 2 times this will be 90. 3, it will be 150. 4 will be 4 times 65. That will be 260. 260. Then 70 times 5, it is 350. 70 times this is 420. Then 7 times 8 is 560. X squared will be 1, 4, 9, 16, 25, 36, and 49. So let's get the summation. Summation of x will be 3, 6, 10, 15, 21, and 28. That will be 28. Here it will be 40 plus 45 plus 50 plus 65 plus 70 plus 70 plus 80. That gives you 420. So we get 420. That is the summation of y. Summation of xy, it will be 40 plus 90 plus 150 plus 260 plus 350 plus 420 plus 560. That will be 1870. Summation of x squared, it will be 5 plus 9 plus 16 plus 25 plus 36 plus 49. You get 140. Now, if we go back to the equation, b can be given by n, we count the number of items. This is 1, 2, 3, 4, 5, 6, 7. So n is 7. So we will say this is 7 times summation of yx, summation of xy is 1870, minus summation of x is 28 times summation of y. Oh, we didn't have y. Oh, we have y. Y is 420. 420, yes. Divide by n, 7 again, times summation of x squared. X squared 140 minus minus into brackets, summation of x 28, then we square. So that is how we get that. So let's get the numerator. The numerator is 7 times 1870 minus 28 times 420. That gives you 1330. Gives you 1330. Divide by the denominator, 7 times 140 minus 28 squared gives you 196. That gives you 196. So 1330 divided by the answer, you get 6.78. 6.7. If we round it to 2 decimal place, will be 6.79. So that is the value of B. That is the value of B. We go to value of A. A is given by summation of y, which is 420, minus B, that is 6.79 times summation of x, which is 28, divided by n, divided by 7. So that will give us the value of A. So let's see, 420 minus 6.79 times 28 divided by 7 gives you 32.84. So A is 32.84. So that is A and that is B. So the first question was asking us to get what? The fixed and variable cost components. This is the variable cost component and this is the fixed cost component. Roman 2 was asking us to get the equation. The equation in the form y is equal to A plus B x. So the cost equation or the cost function, we have A, we have B. So we come and get what? X. We come and get Y. So we can come and check from these points that we have, or we can come and fix in the values that we have, because we expect Y to be equals to 32.84. That is fixed cost plus 6.79. So you can see that is exactly what we have. So if they asked us to get the equation will be y is equal to 32.84 plus 6.79x. Now that equation can be used to predict or to estimate the cost of producing any number of units. Like for example, in this question, Roman 3, they asked us what will be the cost of producing 850 units. So 850 units will be just like this. We will come and say y is equals to A, which is 32.84 plus 6.79 times what? 850. Now, one thing you need to know is x, we had some zeros up here. So those zeros, they have been taken by that 850, it has no problem. So the part that we need now to get the right figure is this part, because we were talking of thousands. So that means fixed cost here would be multiplied by 1,000 would be 32,840 plus 6.79 times what? 850. And that is how we will end up getting the total cost, which is y. Therefore, we can say y is going to be 6.79 times 850 plus 32,840. That gives you a total of 38,611. That will be 38,611. 38,611.5. So that is how we can now estimate the cost of producing that number of units based on that equation. So that is the example. Now we go back to the question that we were given. We go back to the question we were given in May 2018. That question, we've used it before, and it has Roman 2 that we will manage to work out in the next session. Thank you. See you in the next session.